Okay, yesterday I introduced the concept of operator overloading. We said that with the operator overloading, we said that whenever the compiler sees such an expression, a plus b, okay, whenever a compiler sees such an expression, a plus b, it thinks that there is either a function named, global function named operator plus, which will take two parameters a and b, or the compiler thinks that there is a member function of the class that a belongs to, okay? That member function name is operator plus, and it will take a parameter like b, okay? So whichever that is, it's going to call that one. So if you overload this one, okay, then you are overloading this operator, or if you overload this one, then you are overloading this operator. If you overload both, the compiler will tell you that there is an ambiguity. I don't know which one to call. Okay, it's like defining two f functions with exactly the same signature. Okay, when you call it, it's not going to know which one to call. That was the basic idea, the basic mechanism of operator overloading in C++. Note that operator overloading is not a principle of object-oriented programming. Many object-oriented programming languages, including Java, they don't offer any way of overloading your operators. That will be something specific to C++. And as I said earlier, many people don't use operator overloading much. So why are we talking about it? Because it's a good topic that refers to objects and classes and the operators and the references, internal structure of a class, encapsulation, and etc. So it's a good chapter for me to review some stuff that you have already learned. Okay, good. So let's move on. We already talked about those, and this was the first global function operator overload with a plus. We have three constants. I will not modify any of my parameters, and you cannot modify the object I am going to send you. Okay, you cannot modify it because I am going to return a money object. This is how you return a money object. The alternative would have been this. Alternative would have been this. Alternative would have been money, temporary money, okay, final dollars and final cents, and then return T. Okay, so this is alternative to lines of code. Usually we do it this way, just a single line. Okay, good. Then the operator overloading for the is equal to sign. That's it. We talked about those, and this is the real implementation. If both dollars part and the cents part are the same, then these two money objects are equal. Okay. See, I mean, this is our code. I can do whatever I want in operator equal to, or I can do whatever I want in operator plus. Okay. I can implement my operator plus if I like. Okay, I can implement my operator plus. Where is my operator plus? Yeah, I can implement it like this. Okay, cout. Okay, random text and return money to 30. That's it. What would the compiler say? The compiler would say nothing. This one will compile. This one will run. Does it make any sense for this operator plus to behave this way? Of course not, okay? So some of you might be wondering, I mean, why are we naming it like operator plus? Well, it's your problem. I mean, you named it, you implemented it. When you are overloading a new operator, okay, when you're overloading a new operator, you don't have to follow the semantics of it should mean something about the plus operation, okay? The compiler wouldn't know the meaning of plus operator. Compiler will tell you whatever you want it to do, okay? If you want your compiler to do this, then it's going to do it, but at the end, it's not going to make any sense for your customer, for your end user, okay? When you say operator plus, it should mean something about the addition. It should mean something about bringing together two objects and returning something like that. Okay, so it is your responsibility to give a new meaning, to a new meaningful meaning to this operator plus. So this is completely garbage. Let's get rid of it, and this is a little bit better. Okay. Better thing is this other overload. This one is because this can handle the minus signs too.
How can we do operator overloading for stream extraction operator for C?
We didn't come to that yet. We'll talk about it.
In homework we need it.
We didn't talk about it. We'll come to that. Okay. Did anybody hear what he asked? Abdurrahman asked. Anybody? So from now on, say it louder. Okay. Let's move on. That's one thing that we said. I mean, it is your responsibility as a software designer to come up with a meaningful overload of this operator plus. As I said before, the compiler doesn't care what you are doing in this function as long as you return the money, as long as you take these two parameters. Okay, so is equal to that way, yeah. So it is implemented this way. Sometimes you might say that, okay, in my world, we don't compare the cents part. If two money objects has the same dollar amount, then I can say that these two things are equal. Okay, so then in that case, you implement your equal to operator that way. Okay, we already talked about it. Constructors returning objects, and it is we are talking about this plus operator. Okay. So why are we returning a const? We talked about that, and I think it was this. We talked about this too. I mean, it is perfectly okay to write such a thing. It is compiler lets you write it. I am adding two money objects, okay, and I am printing the results to the screen. That's fine, okay. This is good, legal, and it is intuitive. How about this one? Okay. How about this one? I am adding two objects. It is returning me a new temporary object, and on that temporary object, I am calling this input function, and this input function is going to modify that temporary object from the numbers that I entered from the keyboard, and after this line, that temporary object will go away. So where did the numbers I entered go? Okay, that's not a good thing. It is legal, it compiles, but not useful. To prevent such a thing, then I would make this plus operator return a constant object. Since input is not a constant function, it modifies. Compiler will not let you compile this. It will let you compile this because output is a constant function too. Okay. So we define the return object as const. Later, when we talk about C++ 11 features, move semantics, okay, C++ 11 move semantics. We will have some problems with these constant returning functions. We will talk about them when the time comes. Okay, we already looked at this program that's returning and returning variables of the classes and etc. We talked about those. Okay, overloading the union operator. We need to overload such operators from time to time, a minus operator. Okay, and I think we overloaded it, and it was very simple, right? Where was it? think, I think it was number 2. Yeah. See, this one is, why don't I just put it under this one? Okay. So both of them are operator minuses. One of them takes 2 parameters. That means that it's a binary operator because it's a member function. The other one is a unary operator, doesn't take any parameters because it is just returning a money object, which is the negative of this object. Okay. So what other useful unary operators can you think of? This is a unary operator too. This, okay. Minus is a unary operator and binary operator. Plus is the same thing too. How about this one? Is this a binary or unary? Both, right? For integers, it is binary multiplication. For pointers, it is unary dereferencing operator, right? So it is both binary and unary, right? How about, okay, for all the arithmetic operators, how about regular division operator? Is this is binary definitely, 3/5. How about the unary one? I don't remember anything like this, right? Can we write anything like that? Like /a? No. So it is only unary. It is only binary. Sorry. There is a trick here. Okay, this plus is a unary operator, right? I mean, I can say plus a or a plus. It's not a binary operator. It's a unary operator. When I overload it, okay, but I have to overload this one differently from this one, and we are going to see how we can solve this problem. I mean, both of them are operator pluses, right? When I say operator plus, let's say a dot operator plus, which one is this? The prefix operator or postfix operator? Not immediately clear, and we are going to talk about this. What else? What kind of other operators we are going to talk about? Yeah. Well, whenever the time comes, I will talk about them too. And at the end of this chapter, there will be a slide saying that don't do this, this is not allowed, this is allowed, but don't do this, and etc. We are going to do those. Okay. So overloading of money, we already did that. It is very simple implementation. Overloading of the minus operator for the money. I think it is around, yeah, it is as simple as this. So it's not using get dollars, get cents. It is directly accessing dollars and cents, which is not a good thing, as I said before. Even if your compiler allows it, don't directly access your private data. Use the public interface. Don't think about your efficiency. You might say, making a function call is not going to be efficient. Well, I mean, as software engineers, the first thing that you should be worried about should not be the efficiency. It should be your nicely written, disciplined code, okay? Write it the correct way, okay? Use all the object-oriented programming principles that you have learned, okay? Use good software engineering programming practices, and then afterwards, worry about the efficiency. If the program that you write is efficient enough, then why worry? If it is not, then maybe you do some efficiencies, get rid of some function calls, and etc. Okay. Good. So money is defined. Okay, this is good. Minus amount get dollars, minus amount get cents. By the way, this is a global function overload, operator overload. That's why it has to get dollars and get cents. And this is how we use it. This is good. Overloading as member functions, we already talked about those. Yeah. Const functions, we already talked about those. Okay. Which method? Okay, of course, in object-oriented programming, okay, With object-oriented programming, the principles of object-oriented programming say that don't write any global functions, okay? Whatever you write, it should be part of a class. It should be within the principle of encapsulation. How many times did I say encapsulation in this semester? How many times? At least 50 times. Yet when we asked about it yesterday, nobody was able to answer. Why is this happening? Nobody is reading the book. So you don't care about the definitions. You only the compiler is important. We don't care about. I mean, and if you don't, compiler doesn't know anything about encapsulation. I mean, you will never hear the word encapsulation from the compiler in any error messages, in error compiler switches or anything. But yet, the encapsulation is the soul of the whole object-oriented programming C++. Okay, you might think that without knowing this, the keyword, not keyword, but the concept of encapsulation, you can write object-oriented programs. But no, that's not true. You may write programs that will be compiled by C++ compiler, but that doesn't make it. What is that? WhatsApp messages? So put it away. So you might think that it is okay to not to know those kind of concepts, but you are taking this course just to know about those kind of concepts. Okay, those are important. Okay, so encapsulation says that put your data together, define operations on it, and we are going to call them classes, encapsulated structures, nice structures. Don't write anything outside the classes. Don't write any global functions. That's why we should prefer the member operator overloads all the time, but we kind of talked about it yesterday. At least one significant disadvantage with the member overloads, okay, is going to be a few slides later. It's going to come, and we talked about it. Let's look at this operator. We have, I think we never used this operator. No, of course we use it, but we didn't think about it as an operator. It's an operator, function call operator, okay? Function call operator. I can use this, let's say I have a class, an instance of the class. I am using this function call operator like this, okay? I don't know the meaning of it. I mean, what would be money M1 $10.20? Then I am saying money 3, or I am saying money 3 point ABC, comma 2.0. If I like, both of them would be possible. If I overload this function call operator with 1 parameter or 3 parameters, it would be possible to write this kind of stuff, but doesn't make much sense, right? I mean, how am I going to define this? Or if I overload the script operator, does that make any sense? The square brackets? Well, square bracket makes sense for the strings and arrays, vectors, and etc., but not for the money object, right? So maybe I should not overload the function call operator for the money class or the index operator for the money class. That doesn't mean that I should not overload them at all for any class, okay? If the class is right, if the meaning is right, maybe, yeah. Well, this makes sense, right? I mean, let's say I have a string class, string S1, and its initial values are A, B, C. It makes sense to say things like S1, 0, right? I like to give me the initial at the beginning character of the string. This is a good thing. How about this one? S1, 1, comma 2. Maybe I can give it a meaning to this function call operator, like starting from position 1, give me a substring of length 2 out of this string S1. So it's going to give me this BC part, right? This is ABC. ABC, right? So it's going to give me this one. So it makes kind of sense for this function call operator. Kind of makes sense. Okay. So I think I have an example about function. Yeah, here it is. Okay. Function call operator for the money. If I like, I can overload a 2-parameter function overload of function call, operator overload of function call, or a no parameter overload of function call. Both of them are returning integers. One of them takes 2 integers and a double. The other one, of course, doesn't take anything. Doesn't make much sense to overload them, but if you like, you can overload it. The thing is that the number of parameters for a function call operator is not fixed. It is not 0, 1, 2, 3, 4, 5. Okay, it can take as many parameters as you like, because, as you know, with the functions, you can send as many parameters as you like. Yeah.
Isn't it the same as creating another constructor?
No, not it. It has nothing to do with creating another constructor. It is just a. It is. I mean, it's just a name, right? Instead of saying F1, I am saying just operator parentheses or operator equal to.
So it's gonna be default when we call the operator like as empty. It's gonna take.
No, you are confused about this.
Yeah.
When we do this, I am not saying string 1, 2. I am saying S1, 1, 2. You are confused about this. My class MC. I am saying MC1 or MC. I am not saying my class parentheses. To call a constructor, okay, you say the class name, not the object. Okay, you are confused about class name and the class name and the object name. It is okay to get confused. I mean, maybe I talked about the distinction between the objects and the classes. It's a simple concept, but since you don't use it, you get confused from time to time. So the cure for this illness is writing more programs. Okay, good. Let's continue our operator overloading discussion. Remember our overloads? The AND operator, OR operator, and the comma operator. Okay. You can overload them. Yeah, this is possible. This is binary, right? All of them are binaries. But remember, they are executed in like short circuit fashion. What is short circuit? For this one, you evaluate the left side. If it is true, you evaluate the right side. If it is false, you don't continue, just return false. Remember that one? So depending on the left side result, the Boolean, depending being true or false, you evaluate the second side, the right side, right? That was the rule. If you overload these, that short circuit behavior goes away. Okay, both sides will be evaluated. But usually, not to get confused about this kind of a behavior, suggestion is it is allowed. You can yes overload these operators, but usually we don't overload them. Okay, we don't overload them. Okay, another rule. Good. What kind of other operators? I think there was a, where is it? Okay. Some rules. I'm going to come back to this one later, but let's look at them. Okay. When overloading an operator, this is directly from your book. Okay. When overloading an operator, at least one parameter of the resulting overloaded operator must be of a type class. What does that mean? I am smart. I like to overload the plus operator for the integers. So I am writing such a function. Integer returns operator global function plus, and it will take 2 integers. Well, isn't this same as the plus operator for the integers? Yeah, I am trying to overload that one for the integers. No, you are not allowed to do that, okay? To overload, you cannot change any existing behavior of the standard plus operator for the fundamental types. You cannot change the behavior of the double addition or the integer addition or subtraction or division or whatever, okay? So what are you going to do? It says that at least one of your parameters should be a class type. This can be an integer, but this has to be either a money class or a bank account class or day of year class or string class or a vector class. Okay, that's the rule. Okay, so when overloading an operator, at least one of them should be class type. Class type means that a type that doesn't belong to C or C++. Okay, string doesn't belong to C++. It's a part of the standard library. Or vector is not part of the C++. It has to be a class type. But integer, Boolean, double, etc., they are all class types.
It can be enum, strong enum instead of class.
Enum is not a fundamental type. Of course, you are defining enum, right? It can be overloaded with plus. So most operators can be overloaded as member of a class, a friend of a class, or we don't know what friend is. I mean, the name friend sounds nice. I mean, we have friends in C++, but we don't like friends in C++. We are going to talk about them. So most operators can be overloaded as members of a class, okay, non-member of a class, friend or non-friend. But there are some operators that should be overloaded, okay, as members of the class. For example, the assignment operator, it has to be overloaded as a member, okay. The index operator, it has to be overloaded as a member. Remember this arrow operator with the pointers, okay. Since I am overloading them, okay, I don't have to use pointers with them. It is just a overload, okay, this one, and the function operator, function call operator, they all have to be overloaded as, okay, as members of a class. You cannot invent a new operator. All you can do is overload existing operators. Remember the operator table that I showed you at the beginning of the semester, maybe the second week? There was a precedence table, okay? You can overload only one of them. Don't make new operators. You can't, okay? And you cannot change the number of arguments that the operator takes. If plus is a binary operator or unary operator is a binary or unary, you cannot make it ternary, okay? This division operator is a binary operator, that's it. But this operator is both binary and unary, right? Plus and minus, binary and unary. Plus is a unary operator. You may not overload it M1 plus M2. You cannot make it binary. It is a unary, right? So this is not possible. Okay? And you cannot change the precedence of the operator. The operator precedence, remember operator precedence, 3 times 5, or maybe it makes more sense to use the division, 3 over 5 over 7. I know that this 3 over 5 will be done first. Then whatever it returns, 5 over 7, whatever it returns, it is going to return a 0, I guess. 0 over 7 will be done next. That's the precedence. But if I do this, A gets the value of B, gets the value of C, gets the value of 2. This one will be done first, right? Whatever it returns, then this one will be done, then this one will be done. The precedence and the associativity will be preserved, okay? You cannot change the operator's precedence or associativity. Let's say I overloaded the money object, the plus operator, and the multiplication operator. Well, multiplication doesn't make any sense for the money class, but let's say I overloaded it. Okay, this will be done first. You cannot change the order. Okay, this will be done first. Or when I say M1, this is a better example, M2. Okay, so this unary minus will be done first because the unary operators has a higher precedence than the binary ones, right? So this one will be done first and this one will be done next. You can't change the precedence or the associativity of the operators. What else? There are some operators that you cannot overload, the dot operator. Remember that when we say a m1 dot output, that's an operator, and you may not overload it. You cannot overload it. Scope resolution operator, size of operator, ternary condition operator, and dot star operator. Dot star is something similar to, well, dot star is something similar. Well, I don't think that I will talk about it. But you cannot overload it. What?
Is it like arrow?
It is related to arrow, but it is not arrow actually. Yeah, it's related. Yes.
We use double dots on range for loops.
That's not an operator.
That's not
That's not a. We use double dot? No. Oh, you mean the column?
yeah.
Okay. I thought you are saying this like double dot. That's column. Yeah. That's not an operator. This is not an operator when you say for I0, okay, I less than 2 plus I. This is not an operator. This is not an operator. This is the part of the syntax, right? When you make a function called f2 semicolon, this is not an operator, okay? That's part of the syntax. This is how C defines it. You say that you use this special character here and etc. By the way, this one is not an operator either for this parentheses. Okay, good. And as you might expect, an overloaded operator cannot have default arguments. That would be funny, right? I mean, if I have an operator overload, such as this, okay, such as, okay, let's say M2 is a money object. If you don't give me a second parameter, I am going to take it as this default argument M2. How am I going to use it? M1 plus semicolon, right? It looks funny and it doesn't make any sense. So no default arguments for the operator overloads. Okay. So let's go back to slides. Many exceptions, many rules that you don't have to follow, but you should, right? Like don't do this and don't do that, etc. The compiler allows it, but don't do that, etc. So let's go back and let's look at this one. Okay, I have 3 money objects. I like this notation, and this one will work with our class. This one, why? Let's make not explicit. Okay, because this plus operator needs. Okay, one is my object, which is a money object. The other one is money too. But here I am sending an integer. There is no such operator that takes a money and integer. Compiler says that, is there any plus operators defined inside this class? Yes, there is. Does it take an integer? No. Can I make a money out of an integer? Yes. Line 13 says so. It's a conversion constructor. So I am going to make that one. Okay. I am going to make that one, call that constructor, make a temporary money object, and call this plus operator. Test this, okay? Write this program, and compile its code, write a single line of code like this one, like 2 lines of code. M1 gets the value of M2 plus 25, and put a cout statement inside this constructor, single parameter constructor. You will see that when you call the plus operator, it is calling this constructor automatically. Okay. So in this line, okay, in this line, a constructor will be called. Okay. No, a constructor that will take a single integer as a parameter. This will work, but this will not work, because when this happens, the compiler, what did the compiler say here? Inside this money class, is there an operator plus defined? Yeah. Does it take integer? No. Can I convert an integer to a money? Yes, then I will do it. How about this one? Inside the integer class, is there a plus operator? Yes. Can I convert a money object to a integer? Is there such a constructor inside integer? Of course not. Integer doesn't know about money, so this will not work. So how are we going to do that? Unfortunately, in this case, we are going to overload the plus operator as global functions. If you overload the global as global functions, the compiler will ask this question: is there an integer? Yeah, there is an integer class. Yes. Is there a plus operator in it? Yes. Can I use it with money? No. So I am the integer class has no use for me. Is there a global plus operator? Yes. Does it take 2 integers? No. Does it take 1 integer and 1 money? No. Does it take 2 integers? Yes, it can take 2 integers, but this one is a money. Can I convert this money to an integer? No. But I know that I can convert this integer to a money. So it will work for the global function overloads of the plus operator. Unfortunately, to be able to handle these kind of cases, I have to overload my plus operator as a global function, which is against the rules of the object-oriented programming. But I mean, if you like to execute this line, not if you say that I am okay with this, just this one, then you are fine. But if you need this one, then you need to overload your plus operator as a global function. Okay, and some people said that, well, I mean, other than the global functions being not in the philosophy of the object-oriented programming, other than that, they are inefficient because they cannot access the private data members. They cannot access the private functions, right? They are globals. Okay? Some people listen to this complaint and they made even a bigger mistake. They said that, okay, we are inventing something named friends. We are going to do this. And you will get shocked. Everybody will get shocked, but it is part of the, I mean, you are grown people. I mean, you will get used to these kind of decisions. The world is not a nice place all the time. So this is a plus operator, global plus operator. See what it does? I will take 2 money objects and I will access their private parts directly, even though I am a global function. Because this class says that there is a plus operator, global plus operator overloaded, global plus operator. And this class, global plus operator, will take 2 constant money objects and it will return the constant money, and that global plus operator is my friend. Okay, the class says that it is my friend. Since it is my friend has access to my private data members. So it is a complete violation of the principle of encapsulation and information hiding and whatever you call it. Okay, almost all the principles that I told you. Okay, you are letting a global function access your private fields. which is all against the object-oriented programming rules. But you might say that, what did I say? First, try to write correct code in terms of object-oriented programming principles, right? And then if it doesn't work, maybe you will do some compromises, right? You are going to say, well, I know that this is against the rules of object-oriented programming, but okay, I'm going to make them friends. And you might say that still, I mean, I am letting them access my data members. They are not ordinary global functions. Other than these 4 global functions, nobody have access to it. So I am kind of in control. I am not letting, like in a wild way, I am not letting everybody access my private data. I am just letting these 4, okay? And I wanted to make them my member functions. But if I make them member functions, that I will not, I won't be able to do things like 25 plus money. So these are global, but treat them as like my member functions. So this is the explanation. Okay, you had a question, yeah.
Why this is against object-oriented principles? I'm asking this because both member functions and these friend functions defined by class.
Yeah. Well, I mean, encapsulation says that define your data, okay, and most of the time make it private, and only your member functions can access your private data, nobody else. And these are globals. We don't like globals.
But we define them.
Well, yeah, that's true. I mean, that's why the friend people, the people who invented the friend, they said that these are not ordinary global functions. I mean, I couldn't put them in my class. I mean, if I were able to, yeah, I would have done that. But I'm going to define them like globals, but they are part of my encapsulation principle. Then think them as part of this class. They are encapsulated. They say, the other people say that no, C++ is not a pure object-oriented programming language anyway. You are doing this and this and that. Well, I mean, the other people are like usually the mathematic majors, okay? Pure object-oriented people. Yeah.
Can friend function access in-class private member?
Sure, yeah. That's what we are saying. That's what we said, right? This is a friend function, operator plus. See what it does? It doesn't say get sense, it says dot sense.
No class, in-class.
What?
We declare a class in our
Inner class.
yes, inner class.
Whatever a member function can do, the friend function can do the same thing. It is exactly the same thing. It is treated exactly the same way. Okay? So friends are, okay, friends are the functions that you say in your class definition that you declare as friends. You say that there is a global function. It doesn't have to be an overload, just another global function. There is a global function, as that global function is my friend. That's what you say. Friendship is given, it is not taken. Okay? See, this function, it is not say that I am a friend of class money, right? It is just a regular function. It's a regular function overload, global overload. So it is not taken, it is given. That class has to tell the compiler that this function is my friend. Okay? Yeah.
Can we use a friend function in another class?
The question is, can we use a friend function in another class? I think you mean that a friend function, can a friend function be friend of 2 different classes? Yes. I mean, let's say I have money class and a bank account class. Both of them can say that this plus operator is my friend. Good. Any other questions? Okay.
How can operate plus function can be friend another different class?
Well, inside that class,
Parameters of function is
well, it doesn't have to take 2 money, right? It can take a money and a bank account, right? So it can take, or inside it, this operator plus defines money objects and bank account objects and string objects, everything, and it can access their private members. It doesn't have to take them as parameters all the time. Understand? Your question is, how come a plus operator can be friend of two different classes? Well, you define it as a friend inside those classes, and inside this function, I can have members of a money class, members of the bank account class, members of the day of year class, right? I can define them. And inside this function, I can access their private data members.
But parameters are different. Yeah. How can we access them?
Okay, let me type it. Let's say this operator, forget about it, okay? Let's say I have a void function f. This void function f is friend of, okay, both day of year, okay? Day of year class said that this is my friend, and it is a friend of money, m, and it's a friend of, let's say, what kind of other, okay, bank account B. I can say things like cout d1 dot day and m dot cents, and I see I am directly accessing all of them from this function because f is a friend of all of those classes. Inside those classes, class said that f is my friend.
Yes, okay, I understand, but operator functions need two different parameters for class, but we have three different class. How can we class two different class? For example, if I can.
Do you mean that making this operator plus friend of more than one class doesn't make any sense? Well, you suggested if I can make it, and I said yes, you can, and now you are saying that it doesn't make any sense. Well, it is not up to the compiler what your decision is. I mean, mechanism-wise, yes, this operator plus can be a friend of 100 different classes. You are saying that it is not useful. Yeah, you are right. Okay, it was your suggestion that can I make the, okay, you are making friends and you are saying that I don't like these friends. Well, if you don't like your friends, delete them, okay? Yeah.
Friends provides that private members, class private members.
Yeah.
Get, I understand it, but look at this. I access the cents or dollars member.
Yeah.
Get function provides it.
Uh-huh.
And not useful.
Well, no. Well, again, I mean, if you have such a need of this function being a friend of many different classes, you are in a very, very, very bad situation in terms of class design. I am not talking about friends are bad, okay? The name friend is good, but in C++ friends are bad. We don't like friends, okay? Don't make any friends. Be cohesive and be sufficient for yourself. Whatever you need is defined inside the class, okay? Your customer should know it that way. But I'm giving these examples just to tell you what friends are, what they are capable of. We don't like friends at all, okay? By the way, I can define friends as see, this is a global function friend. I can say this function, remember, yeah, this void function of class day of year. Remember, day of year class has an output function. Okay, that function is my friend too. If you like, you can say that too. So you may define another class's function as your friend, if you like. This is possible too, but again, we don't like this line, okay? Any line that starts with friend, we don't like it. If you don't have to, then don't use friends. I defined these friends just to get okay, just to get this line going. Without friend, well, I mean, this one doesn't have to be friend. This one doesn't have to, of course, this one doesn't have to be, okay. This one doesn't have to be friend if I had accessed the sense part using the get sense, get dollars interfaces, right? Then that would have been, okay, why do I need to be a friend? But sometimes these cents and dollars, they don't have getters, okay? They are private data members. There is no way to access them. Sometimes there are very useful private functions to call, okay? That way I make them friends, okay? I mean, it would have been okay. It would have been okay for me to skip this friend discussion altogether in C++ and don't mention about it. Like nobody teaches you the go-to statement in C, right? They say that don't use it. There is a go-to, but don't use, etc. I could have said the same thing, don't use it. There is a friend keyword when we are not using it. But again, when I talk about the friends, then it gives me some opportunity for talking about the encapsulation principle of information hiding and that kind of stuff. What is possible with C++ is different than what you should do with C++, okay? Compiler is, of course, compilers are our friends, they are tools, okay, useful tools, but they are not everything. Whatever the compiler says is not true about object-oriented programming language. Of course, if compiler rejects something, then I can't compile it, so I have to do something else. But if compiler accepts something, that doesn't mean that you are doing the correct thing. Okay. So let me take what did you eat? He keeps asking questions. Okay, that's good.
What will happen if I put friend function in private section? Can I add
Doesn't matter. Yeah, that's a good question. Doesn't matter where you say your friend is. I mean, these are not in public section. This could be in anywhere in your class definition. It has exactly the same meaning. Okay. Some of the questions are actually, what was your name?
Hamza.
Hamza. Some of his questions are mechanism questions. He say that what would happen, compile, what to say. The other thing is, why do I need it? I mean, why in object-oriented? So some of them are philosophical questions, some of them are mechanism questions, and it's important to know the difference. I mean, why are we doing this? How can we do it? Two different questions, very different questions. Before we leave for the break, let me get some attendance for your benefit. Do I have to do this all the time? I guess yes. I guess I have to do this all the time. I have to log in. Enter my password. Then when I do this, all the guys sleeping over there, they just wake up and they do this. I am gonna say, yes, I am here. This is my time now. Okay. So is Bilal here? Bilal? Ali Fırat? Talha? Kaymak? Abdullah Göktürk? Abdullah, are you here? Abdullah, you scared me. You are Abdullah Göktürk, right? Are you guys, so you are sitting on, each of you is sitting on a different seat, right? It looks like you are crowded. Okay, that's good. Eren Torlak. Eren, you are here. And today is 25th. Where is my, okay. What? Selim, you found a way. Okay. Where is Selim? Selim, congratulations. So you are faster than Usain Bolt, right? It is. He's 8 seconds. You are 9 seconds something. Yeah, good. Okay, so let's take some break. After the break, we will continue about this. Finish up with operator overloading.
Hocam bir şey sorabilir miyim? Hocam
Daha bitmedi mi sorun ya?
Hocam ben yakalamayı unutmuşum da gene.
Unuttuysan yok.
hocam biz her obje tanımladığımızda datalarımız yeniden tanımlanıyor ya. Fonksiyonlar için de geçerli mi?
Değil tabii ki. Function bir tane.
Bir tane.
Evet, ve fonksiyonları tekrarlamanın bir manası yok. Aynı datanın üzerinde çalışıp duruyor.
Peki biz obje tanımlamadan bu fonksiyon herhangi bir memori değer kaplamıyor.
Tabii ki.
Kaplıyor.
Onlar yükleniyor, bir yerde bekliyor. Bir şeyin üzerinde çağırdığın zaman nedir? Tabii sinüs fonksiyonu hafızada beklemiyor mu? Çağırsan da çağırmasan.
Bekliyor.
Tabii bundan aynısı.
Peki o
Esasında
memori
bu fonksiyonları global fonksiyondan farklı düşünme. Onlar global fonksiyon hepsi. Yani normal SMB'de fonksiyon neyse onlar o. Onlar o. Sadece compiler o fonksiyonların bazı objeler için çağırmasına izin veriyor, diğerleri için çağırmasına izin vermiyor. Global fonksiyon hiçbir farkı yok hatta.
Peki biz diyelim ki herhangi bir member function'ın içerisinde tanımladığımız diğer member function'ların adresine ulaşmak istesek buna ulaşabilir miyiz?
Tabii.
Nasıl yapacağız?
Fonksiyonu nasıl, fonksiyon adresini nasıl alıyordun? Fonksiyonun ismi adresi esasında. Money, 2 nokta üst üste, output, onun adresi.
Tamam hocam teşekkür ederim.
Doldurmam gerekiyor mu kağıt? Yok demek kaçırdım ya kağıt. Doldurmam gerekiyor.
Kaçırdıysan gelmedin sayılıyor, bilmiyor musun?
Yani geçen haftalarda kağıt doldurduk da.
O geçti artık.
Hocam bir şey soracağım. Bir member fonksiyon bulunduğu scope içerisine çağrıldığında o scope içerisinde tanımlanan bir değişkene ulaşabilir mi? Bunu başka bir şey için soruyorum.
Nasıl ulaşacak ki o member
Ulaşamaz,
fonksiyona
değil mi?
parametre olarak göndermen lazım.
O yüzden preend global functionları gerçi gene aynı.
Aynısı yok.
Ona da
Senin kafan karışık. Onu aynı soruyu C'de de sorarsın. Cevabı da tabii ki nasıl edeceksin? Sen Python gibi düşünüyorsun. Python gibi.
Böyle yapsam direkt abi. Ama o zaman da gelmediği dersler de geliyor. Sana nasıl olacak? Ne diyorsun? Geliyor. Gitti abi. Emre.
Giderim ya. O zaten sanatta dedim. Sınavları zaten sanatta. Hala sanatta. Zaten sanatta. Dersler bittikten sonra sınav başlıyor.
O ne diyorsun?
Bizim okulda
Ha, o anlamda sanat.
Gel. Öyle değil mi? Bizim
Evet evet. Hatta bir haftalarda boşluk bile vardı.
kaç hafta kaldı? 8.
Bir hafta buna gelmedim. Bir hafta geldi ama 14 hafta mı? 14 hafta 104 gelmiyor. 4 hafta. 4 hafta gelmiyor. 4 hafta yani. 4 hafta dersler gelmiyor. Hafta gibi değil. Hafta %120 mi? Wake him up. Yine böyle kafasına vuruyor. Abi ben dersimizi Erdem akıyor hocam. You don't like him oğlum, nasıl şey yaptın? Lili'de de yok. If you don't like your friend. Sağa değil, sola kaydırıyor. Klasal var mı? Daha iyi programcı ama manyak. Çocukların bir şey olarak onu gözlemliyoruz. İlginç bir kurgusal karakter olarak böyle. Eleman daha iyi ama neyini ya?
boş. Hiçbir şey yapmazsa, onu ileride kullanamazsa boş.
Niye uyutmuyorsun lan zaten? Niye uyutmuyorsun? Uyuyamadım mı?
Ama gözümü açamıyorum. Uyudum. Öyle. Yetmeyemez.
Sporda yapmam.
Yetmeyemez.
Kaç saat uyudun oğlum? Arkadaşım diyecek. O kim abi? O Kina. Ya şey var onun sorumlusu var. Toparlan bırakma kafayı.
Acaba hala şundan mı? Sadece overload edersin. Yani burada aslında overload ediyorsun. Çünkü genel eşyalar. Sen yazmasan da bir tane default oluşuyor. Hatta şey demiştim. Default contract'ta no parametric constraint. Aslında bir default contract dedi. Bu no parametric constraint. Hiç parametre almıyor. Sadece iki parametre alanlar yapıyorsun. Default contract'ta da akıllı oluşuyor. Ya şurası çok gereksiz boşluk. Evet. Ben o yüzden ama hangisinden yani ikili üçlü alırsam yüzde yakın şey daha da güzel şey. Ben şeyi fark etmedim ya. Bana sormamış. Ben nerede maksimum bu ilacı işte bir tuz oldu. Böyle kesin böyle. Sonra falan orada bir şey olmuş.
Beş kere secde edin. Beş vakit. Beş. Sen şöyle da yazdın mı? Hacım yaptım kalkınca fark ettim yaptım uğraştığım şeyin gereksiz olduğunu fark ettim. Sonra daha kısa bir yol dedim. Hani dörtmeyi tam olarak tamam ama varsayımlar yaptım işte böyle basic dediğin şeydi. Çünkü belirsizlik var orada.
Sen şu süreyi yine söylesene bana. Ya şimdi değil mi?
Şey yapacağım ya. Configuration.
Hoca umarım laptopu kısmadan halledebilir.
Yapıyor bir şey.
Diyeceğim ki hocam telefonu internete bağlar mı?
İşte desem daha iyi.
Ama o da aslında
Şey olarak yani tanıştık da yani adam öğrencileri pek umursamıyor belki. Yo, belki tanıyordur yani görmüştüm falan. Vektörle görüşmedik ki oradaydı forma yaptık. Yani bizim hocayla öyle bir şey yok.
Şey falan yapmadım, matematik yapmadım. Üçse şöyle olacak. Birse şöyle. İkisi şöyle. Onu da
kardeşim meslek sıkıntısı. Bir daha söyleme.
Ne olacak oğlum?
Şimdi bir kod benzeyecek şey yapacağım. Yani bakalım abi. Lütfen bahsettim işte. Olayların transkriptörü ayrıca kasmaz lazım. Adamın değerlendirici nasıl
Böyle güzel.
Ben çarlaşadım.
Bizde iş yok. Abi bunlar adam alıyor.
bu dönem gidecek işte bu dönemde beraber.
Bugün bana
Dönem hoca.
yani bu dönem sana başlayacağım. Şimdi var ya şey
Kaliforniya. Görüş şeyi. Şeyde var mı?
Okay, let's start. Çay kaça kahve şeyde kantinde? Çay? 2.20. Çay evet. 2.20'yi nereden buluyorlar ya? 25, 20 değil yani. Tamam. Simit falan ne kadar? O kadar paramız yok hocam.
Ben de onun bilgisini öyle bir talimat geldi. Ana bir forma çalışıyor. Hemen
Okay, before we start, don't forget about the attendance for the second hour. Okay, so this is the reason why we need global function overloads in order to not get hit by the access privileges problem of the global overloads. We make these functions friends, and that's why we need friends. And without the friends, actually, we can live through the public interfaces of the classes, but sometimes public interfaces are not enough. And we will see more examples of friends in a few minutes. Okay, so friends not pure. Yeah, object-oriented programming says that operators and functions be member functions. Many believe friends violate the basic object-oriented principles. Well, there are certain advantages. Automatic type conversion is something. Okay, because of this type conversion, okay, I don't have to overload this plus operator for many and integers, many and double, and etc. Right? It is automatically done. Okay, so this line is nice. This line I can handle this line because I have this. Where is it? Okay, I have this conversion constructor from the doubles, and I have this conversion constructor from the integers. Okay, I can handle it, but to be able to handle this line, then I need to overload this plus operator as a global. Okay, so I cannot avoid global functions, and by making those global function friends, I am kind of saying that those are global, but I mean, consider them as like my member functions, okay? Because I have written them. I think you said that, right? I have written them. I know what they are. I know how they access my data, so they are okay with me. It is not like your customer's code can do whatever they want. Okay, so we talked about that friends and friends not pure, and well, they have their advantages and their efficiency and etc. Well, as if the friend functions are not enough, we have friend classes. Okay, you may define a whole class as your friend. This is how you do. Okay, you will say that class C says that class F is my friend. Okay, so what does that mean? Inside this class F, all the member functions of the class F can have access to the class C's private data and functions, etc. Okay. So two classes. Well, classes cannot be friends actually. I mean, one class says that this class F is my friend. That doesn't mean that the C and F are friends. F is a friend of C. Okay. C is not a friend of F. So friendship is given, not taken, and it is not symmetric. Okay, so the term when I say two classes are friends is not a correct term. It says F is a friend of class C. This line says. If I like to make C, okay, don't forget about your attendance, online attendance. If I like to make C class C friend of F, then inside class F I should say C is my friend. Okay, But the thing is this, since I am declaring class C before class F, compiler doesn't know anything about class F, right? Compiler doesn't know anything about F. What is F? F is a class, F is a function, is a variable, it doesn't know. So that's why we have this forward declaration. You say that I am going to define a class named F later. You don't know the details of the class. Its name is F, it's just a class. In that case, I can say F is my class. Otherwise, if I don't say this line, the line above, okay, this line is a compiler error. Compiler doesn't know anything about F. This is called a forward declaration. Without the forward declarations, it is difficult to say that one class is your friend. You might say that why don't you define class F before class C? That would solve the problem, right? Forward declaration. But that has a bigger problem. What is the problem? Okay, to solve this problem, get rid of this line, put the definition of class F before class C, and now I don't need the forward declaration. Yeah.
How is the class F going to access the members of class?
Exactly. Say it louder.
If we declare class F before the class C, the F won't be able to access the members.
Yeah. I mean, what is the meaning of F being a friend of class C? Inside F, I am going to access the data members or the private function members of class C, right? But F is defined before C. The compiler doesn't know about C, right? So, as I said, without this forward declaration, it is very difficult to have this friendship relationship. So we do it that way. So again, we don't like friend classes. We don't like friend functions. Don't use them if you don't have to. Okay, use them with caution because they are all against the rules of basic object-oriented programming. I mean, if two classes need to be friends, maybe they are the part of the same class. Maybe you are designing your class structure wrong. Okay, so think of it like this. I mean, C is a programming language where there is one huge class, okay, one main class, and all the global functions are part of that class, and everybody is everybody's friend. Okay, C is a programming language like that, but that's not that doesn't make it an object-oriented programming language.
So when we say inside class C friend class F, does we meant C class can access
Exactly, like a friend function F. That function F can access my private data in C. Now, friend class F, the functions of class F can access. It's like my friend class, friend functions. Okay. So if I have a function F here or G here, F and G can do whatever they want with my private data of C. Okay. Good. So most operators can be overloaded as members of a class, a friend of a class, or a non-member or non-friend. We already said that, and we went over that. Any questions? So friendship is a bad thing. Don't try to be friend with anybody in object-oriented programming languages. And in Java, there is no friendship. They say that, no, we don't do that kind of stuff. And in Java, we don't have operator overload. Operator overloading makes C++ a little bit complicated. Okay, because of the operator overloading, we have to do this friendship. Because of the operator overloading, we have to write global functions, etc. Java solved this problem. No, you are not going to overload any operators. If you need to add two money objects, then write an add function, right? ADD, add function, that's it. Why do you have to use the plus operator? Okay, let's move on. References, we already know that, okay? There is an integer Robert, and I have a integer reference Bob, which is a reference to Robert. So if I change the value of Robert, the value of Bob changes. So they are two different names to the same memory location, you might think. Okay. So what is the point of writing this? I mean, if I'm going to modify Robert, then I would modify Robert. Why do I need Bob? Well, this is just to demonstrate what a reference is. We don't use references like that, of course. We use references to pass our data to functions using call by reference, right? That's one thing. That's where we use. The other thing is sometimes we return references from functions. Okay. Let's look at this example, the sample function. Okay. The sample function takes a double reference and returns a double reference, and that's what it does. Very simple, stupid, trivial, use this example. Just shows a concept only, but it's just an example. So how am I gonna use it? Let's write some code. Double D1, the first value is 1.7. Then I call this sample function SF D1. Well, of course, this is not going to do anything, right? I mean, when I say, okay, cout sample function D1, this will print 1.7 on the screen. It is returning a reference, but yeah, it's returning a reference. That's true. Okay. How about this one? SFD1 gets the value of 2.7. Can I write it? And yeah, the answer is yes, of course, you can. Why? Because it is returning a reference, and references are actually L values. Remember our distinction between L value and R value? L value is something that can happen on the left side of an assignment operation, right? So L value, R value. L values are the ones that can happen on the left-hand side of the assignment. R values are on the right-hand side of the assignment operator. L value and R value. So the references can be on the L values. Okay. So this could be something that we can do in C++, but not in C, but in C++. Because in C, only you can return values from functions, not references. In C, we don't have references. The best we can do in C is returning a pointer, but that still would be a value, right? A pointer value. We can dereference it, then I can get an L value. In C++, without the dereferencing, I just return the reference and make this assignment. That doesn't seem very useful, especially with this function. That's true, but when it comes to operator overloading, this is very important. Why? Because let's say I write this string class, okay, S1, its initial values are always, like always, ABC. When I do stuff like this, okay, this index operator is an operator, right? It's an operator overload. Well, what kind of thing it is returning so that I can do this assignment? Well, this index operator should return a reference, right? So that I can do this assignment. So I need references for the operator overloading so that I can return them and somebody use them as an L value, not an R value, but as an L value. Okay, let's see one example of it from our book. Maybe this one. Is this one a good one? No, not well. I think I'm going to do this. Do this here, okay. Very, very simple class, character pair class. Before using it, let's see how it runs actually. Character pair A and constant character pair CP. So character pair, as the name implies, it keeps two characters. I can give see the constructor. There is a no parameter constructor. It doesn't do anything. And two parameter constructor. It takes the first value and second value. It assigns the first value to first and second value to second. Okay, that's it. So what am I gonna do? I make two objects, okay, and I do this. A1 means that return me a reference to my second. I think one is index of this one, 2 is index of this one. Well, I don't know how I implemented this. Okay, so I can do that kind of a stuff. I can say A1 and A2 are, and an A1 and A2, yeah. One will return the first pair, the first one of the pair. The two will return the second one of the pair. If I like to make this assignment, I should return a reference. So this is what I'm going to do, and this is the implementation of the whole thing. Well, I think, why don't I do get rid of? I am going to, okay, don't see this line yet. This is the implementation, okay? So this index operator will take a index, integer index. Question, is index operator a binary operator or a unary operator? Binary, right? Why? Because I am using it with two parameters. One is a, the second one is 1, right? It's a binary operator. So as a function member, it should take a single parameter. Remember, we cannot overload the index operator as a non-member. It has to be member. Remember the rules? It has to be a member operator. So it's going to take an integer index, okay? It's going to take an integer index, and it should return a character reference either to the first one or the second one, depending on my index. And let's look at the implementation. Implementation is like this, okay? Let me get rid of this. If index is 1, return first. If index is 2, return second. You might wonder why. Okay, let me get rid of this one. You might wonder why. I mean, what is the difference between returning a reference and returning a value? For the return statement, it is exactly the same. Remember our small stupid function? I mean, what is the difference between returning a double and returning a reference? Our return statement is exactly the same. When you say return variable, it's just depending on your return type, it either returns a value or a reference. In this case, I am returning a reference to a variable. Okay, and here we are doing exactly the same thing. I am returning a reference to this character or this character.
What is first and second?
What?
What is first and second? String character.
First and second. Okay, those are two our private characters. Okay, so I am returning a reference to either to this one or that one. If it is out of index, okay, I am saying that illegal index value, I am terminating this program. Okay, that will be it. So this is how we use the index operator. By the way, I mean, it is binary. The first parameter will be my object, the second parameter is an index, but it doesn't have to work that way, right? I mean, I don't have to use it with an integer. I can use it with a double. I can use it with a money object. I mean, it is up to me what kind of parameter this index operator takes. Of course, it makes sense to use an integer because that's how we use the index operators, with integers. Okay, so we started talking about the references. We are talking about references because I need to return a reference. This is how you return a reference, and this is why you need to return references from functions. Some might say that whatever we are doing here is not good in terms of object-oriented programming. Why? Because we are exposing our private data members. That's true. Why? When I return a reference to first and second, I expose them, right? They can do whatever they want using an assignment statement to my private data member. It's like setter, but uncontrolled setter, right? With the setters, I said I mean, this letter has to be between this and this value between this and this. In this case, I can't do anything, okay? Because I gave a reference to the outside world, and they can use it as an L value, and they can modify my private data member that they want.
But we can we can control it with intermediate variable.
How?
We can't we initialize any variable and then check if met our condition, then
How? Where are you going to write that code?
return it, otherwise it won't return.
Well, I just returned the reference, okay? I just returned the reference. These guys take that reference and does this assignment. This is outside of my code. I can't do anything about this, right? I expose it fully to the outside world. That's not a good thing. Let's say I like my characters to be capital letters from A to Z, right? Nothing else. How am I going to do that? I can't. Okay, with the setter, it was easy because I get the parameter. If it is outside this range from A to Z, I would say I'm not setting this. I am terminating this program. But this is not like that. This is, I give a reference to the outside world and they can do whatever they want. So returning a reference from your class, you should be something careful. In this case, well, any character will do, and I am okay. But again, you are exposing your character reference to the outside world, and we don't like it. We have to be careful about that. Yes?
Can't we use a function to check the viability of the input? And if it is a viable...
Okay, how are you going to do that at line 25? In line 25, my operator runs here and it is done. After that, my customer has the reference to my private data member. And they can do whatever they want. Whose assignment operator is this? This is the assignment operator of the character class, right? This one. It's not my class. So I don't have the control.
But I can control the operator.
Which one? Index operator?
The bracket.
Index operator?
I'm sorry.
Yeah, you are asking exactly the same thing. And his response was exactly the same thing. Okay? So, I mean, the complicated mechanism at the end, we are saying that you can do this, but you should be careful. Something else, something even more troublesome is this. Remember this function? Let's write this function in a different way. I am returning an integer reference from a function named f, okay? The f doesn't take any parameters. Inside this, I have a temporary integer, 2, and I am okay. Return t. Does this compile? The answer is yes, of course. Am I doing a good thing? Definitely a bad thing. Why? Because if somebody says, call me f, it's going to return me an integer reference. I will assign 7 to it. You could do it, but where am I assigning this value to? Okay, where does this 7 go? It is assigned to some integer who is a reference to a local variable. This t will die when this function f ends, right? When this function f ends here, this t will die, and I am assigning this value 7 to a memory location that doesn't belong to me anymore. Okay? The even worse thing is that this will compile and run, and most of the time this will not cause any crashes, and we would think that our code is working. From time to time we will have nonsense results, junk results, and we will not know what's going on with our code. Okay, so we should be careful about returning references. Why don't we have the same problem here? Why don't we have the same problem here? We don't have the same problem because we are assigning this A, this capital A, inside this character pair A, right? So A is alive. It has some memory location available to it, and I am modifying that position. Okay? So in this case, we don't have that problem of modifying some memory location that doesn't belong to us. Good? Any questions? Yeah.
Can we conserve local T that you just?
Can you do what?
Uh,
You are talking about my local, this one?
T. By using pointer, can I use T memory for assign 7? You assign.
Oh, you are saying that allocate some memory.
No allocation. Just I declare a pointer P, start P, assign F, assign 7.
In C.
No, C.
In C++. Well, I mean, yes, of course you can do that. It wouldn't be any different than this. I mean, you are saying that I can have the same problem in C style. Yes, of course. Why not? Maybe you don't say that, but usually I change people's questions, and you are saying that, okay, this is integer pointer, right? And I am just returning an address of T and do this.
Not function pointer, another variable.
Where? What do you mean? This is not function pointer. This is just a dereference.
I declare a pointer
I
and assign to F. I declare a pointer P, assign F, assign 7.
Return value of F.
The return value of is an integer pointer, right?
Yes.
Yes, I am returning an integer pointer.
Yes.
So this isn't this exactly? I mean, just another way of writing what you are saying, right? Instead of making a temporary pointer, I am just returning a. You are saying that. Let's do this. Okay, integer pointer P, address of T, and return P. Is that what you are saying?
Instead of address of T, can we malloc it?
He's not talking about malloc. Okay.
No malloc. For we have written.
So what is your point? If we do that, you are solving something. Well, no. I mean, if you are going to do that, you are still returning a pointer to some place that doesn't belong to you. But if you like to have a pointer that's to a global variable or to a dynamically allocated variable, then you might be okay. But somebody has to take care of that globally allocated variable.
This is out of scope. Declare a pointer P.
Well, that would be you are saying this, okay, that would be returning a reference to a global value. Yeah, that would be okay, but it wouldn't be any different than this, right? You are taking a reference to either a global variable or a local variable to somebody, and you are returning it, so you are safe here because whatever you are taking as a reference, you are returning it. You are safe in terms of using some memory location. So you can do the same thing with the pointers, yes, true. Okay, but still, you have to be careful about returning a reference because you are not making copies of your objects or your values. You are returning references. Yes?
The double reference variable I understood. What happens if we delete the ampersand in that?
You mean like this?
Yes.
If I don't include this ampersand here, you mean here, not there, right? If I delete this, okay, question, nice question. What happens here? Yeah?
It's a copy, so
Say it again.
the parameter is
Call by value.
will be a copy, so it's a temporary object, and
Yeah.
the same problem here.
You are doing exactly the same error that I did here. You are doing exactly something like that because this variable is a local variable now. It's a copy of whatever it passed. It's going to die when this function ends. You are returning a reference to somebody that's going to die.
Solving the code from our textbook was not a good code for that example.
No, why not? I mean, this is, okay, it was like that. And when you call this function SF, okay, it's going to return a reference to this D1, and basically I am making an assignment to this D1. After that, the value of D1 will be 2.7. This is not a bad code. It doesn't have any memory problems. It is useless code, but it is not bad code.
Can you open the textbook code?
You mean this? This is good. This is okay.
Operator overloading.
Well, this is. Oh, you mean this? Yeah, this one. This one doesn't return a reference to your, okay, call by value parameter. It returns a reference to the. It returns a reference to the data member of this object. And this object doesn't die after this operator called. It still lives. Okay? Any other questions? Okay, so this is something, index operator, that we need to be careful about. What else? A few other things about operator overloading. Would I have any time to talk about them? Maybe, yeah, let's start talking about this stream insertion and extraction operators. I mean, it's a trivial thing, but I need to talk about them. Tomorrow, I am not going to, I am trying to test this idea of inverted class. Did you guys hear about it? Something new. Read about this inverted class, inverted classroom. In inverted classrooms or flipped classrooms, okay, you are supposed to read your subject at home. I have videos of everything that I talked about. Better yet, there are other good professors all over the world talking about this kind of stuff. Learn about them before coming to the class, okay? And learn about them before coming to the class. And during the class, we just make this kind of discussion. I mean, I didn't have to tell you everything because my videos are there. Instead of me talking about the subject over and over again, you learn about that, watch the video at home, and come here and ask questions like Hamza has been asking today. So the classroom will be all about asking questions. But tomorrow I will test it. I'm not going to ask you, well, I think I will ask you this. Listen to my videos from last year about, okay, overloading of plus plus minus minus stream insertion and extraction operators, okay? And tomorrow I will get your questions about those to see if this is really working. If it works, then that would be nice because it will be more interactive. I will be spending same amount of time during the class, and you will, instead of you study your lectures late before the exam, you will have to study them before you coming to the class. So you learn about them. I am going to do two things. Okay, I'm going to divide you into two groups. The first group will be in the first hour, second group will be in the second hour. I am going to ask you to write a class during the class, okay, during the lecture, and you are going to submit your results through Teams. So bring your computers, everybody, bring your laptop computers. If you don't have a laptop computer available, which it might not be available for you, okay, so maybe you can share a computer with one of your classmates. So two people using the same computer is okay. Even if you don't have that, okay, you can take a piece of paper and implement your class on a piece of paper, take a picture of it and submit it to our Teams page. And we are going to grade some of your results on the screen here. So I think I'm going to divide you into two. I don't know which one will be in the first session, which one will be in the second session. I think I am going to send you an email after that. So tomorrow I am going to do this. I will say that, okay, I have a class. I will write a main function. In the main function, I will say, Okay, these are my classes C1 and C2. This one can do such and such, and this one can do that. Okay, write this class, the header first, then the implementation later. Okay, I will not grade it. I will not grade it, and we will just see how people are implementing such classes. Okay, so it will cover everything from the beginning of the semester up until the operator overloading, but learn how to overload these before coming to class, because I will ask them.
Which video are they?
Yet?
Which video are these overloading?
I don't know. It is the videos from last year. Just make a search on my name and CSE 241. Let's find them. I think I marked them as the operator overloading. You don't have to watch them from my videos. You can studio. Okay, and my content. I make a search. How do I make a search here? In where? Am I after what?
You up there.
Oh, okay. So CSE 241 fall 221, right? Yeah. So these are the many things that comes, and operator. Do I have anything? No. Wasn't good. Operator overload. Yeah, see this one? 220 operator overload, 220. Is this English? I guess so. Yeah. So November 9th and 10th. So it looks like operator overloading I was doing in November. This year I am a little bit faster. So listen to these. But as I said, if you don't like, I am teaching this to you, just use some other source. So we are doing flipped class, okay? Let's see if it works. If it works, I am not sure I'm going to use it all the time, but from time to time it will be nice. So more time for you to ask questions. Okay, it's not going to make my job easier. Well, at the end, if more people gets a passing grade from this course, my job will be easier. Yes, true. For you, I think, since this is a very large class, I don't think that I can handle all of you 150 people in one session. So I'm going to divide you into two groups, first hour and second hour. I guess that will be it. Okay. You like it? No? I don't care. Yeah. Yes.
So we need to only watch the part about overloading plus plus minus minus insertion.
Stream insertion and extraction. Yeah. The rest of the chapter overloading. Yeah. Yeah.
First section will not join the second section, right?
Yeah. Yes, that's true. And I am going to send you. Maybe I will send you a form saying that which one do you prefer, the first one or second one. Okay. So we will do it that way. Yes. I don't understand you. Say it louder. That's what I said. Share your computer with somebody else. If you don't have that one, then write it on a piece of paper and take a picture of it and submit it. Okay? I can grade it or show it on the screen. If you don't have a cell phone to take the picture, just give your paper to me and I will look at it. Bye. Okay, see you tomorrow.